We're going to now look at a reaction of an aldehyde. The aldehydes. This particular section in your textbook is called Reactions of Aldehydes and Ketones, but we are only going to be looking at a reaction of an aldehyde. And the reaction that we're looking at is called the oxidation of aldehydes. And we have seen oxidation reactions already. We saw oxidation of alcohol reactions a while ago, so this is going to be somewhat familiar. So let's just kind of do a remember oxidation of alcohol stuff over here. We looked at a couple different types of oxidations of alcohols. When we were doing these reactions, remember we were just using the capital O in square brackets as a way of indicating the oxidation process. So we weren't necessarily giving the formulas of the reagents that are necessary. We're just using that O in square brackets. And the oxidation reaction converts a carbon-oxygen single bond into a carbon-oxygen double bond, like this. And we saw that the oxidation could actually be carried out even further. And if it's carried out even further, the single bond between the carbon and the hydrogen, that bond can have an extra oxygen squeezed into it like that. So that was one of the oxidation reactions that we've already looked at. And another one that we looked at used a different type of alcohol. So this is an alcohol that has the OH group somewhere in the middle of the carbon chain as opposed to at the end of the carbon chain. Again, we just use O in square brackets to indicate that a reaction is occurring, an oxidation reaction is occurring. And in this reaction, we're going to convert a carbon-oxygen single bond to a carbon-oxygen double bond, just like that. So this is stuff that we have already done, just as a refresher. For the oxidation of aldehydes, I'm going to do this little guy right here, and we're oxidizing this guy. Notice that this is just simply this last step of the oxidation of an alcohol, starting here at this particular point and moving forward the rest of the way. So when we are doing an oxidation of an aldehyde, we are just doing this part where we manage to magically squeeze an oxygen atom right here in between that carbon-hydrogen single bond, just like that. We have two different sets of reagents that we can use to do this type of oxidation process. One of them is called the Tollens reagent. So it is usually known by its name, Tollens reagent, but occasionally you will see it written out in its molecular formula. The formula for Tollens reagent is Ag2O in NH4OH. So these two are the same thing. One is just referring to it by its name, and the other is referring to it by its molecular formula. And our other option for oxidizing is K2Cr2O7 potassium dichromate. Potassium dichromate also oxidizes alcohols. So potassium dichromate oxidizes alcohols as well as aldehydes. Tollens reagent only oxidizes aldehydes. And so this gives us a little bit of versatility when we are trying to do an oxidation reaction. Let's draw a couple of examples. We're going to start with just an aldehyde. And let's use K2Cr2O7. But we're also going to do this reaction with Tollens reagent, and we're going to see if there's a difference in the products that we get from these two different reagents. So when we're trying to predict the products of oxidation, the first thing that we should look for is a carbon-oxygen single bond. If we have a carbon-oxygen single bond, we're going to want to convert that to a carbon-oxygen double bond. If we go back up here to this all this highlighted mess that I've made up here. The first step in both of these reactions is converting a carbon-oxygen single bond to a double bond. Single bond to a double bond. So when we're down here and we're trying to predict the product of an oxidation reaction, the first thing that we should look for is a carbon-oxygen single bond. If we had one, we would convert it to a double bond. However, in this case, we do not. We are starting with a carbon-oxygen double bond. When we're starting with a carbon-oxygen double bond, then what we're looking for next is this carbon-hydrogen bond right here. Because the next thing oxidation will do after making a carbon-oxygen double bond, the next thing that's going to happen is that magical squeezing of the oxygen into that carbon-hydrogen bond, like that. So that's not so bad. Let's try another example. This molecule is going to be a little bit trickier. So we have our aldehyde, like we would expect. We're going to oxidize this again with both of the reagents, K2Cr2O7, and we're also going to oxidize this with Tollens reagent. And see what we get. Now, when we have two functional groups, we have an alcohol and we have an aldehyde. We do have to be a little bit more careful about what's going on with these different oxidizing agents. So going back up to our list right here, the Tollens reagent only oxidizes aldehydes. So let's do the Tollens reagent first. The Tollens reagent only oxidizes aldehydes, which means that the alcohol is not going to be affected at all by the Tollens reagent. What can the Tollens reagent do? Well, it cannot make a carbon-oxygen double bond because that carbon-oxygen double bond already exists. So instead, what it's going to do is squeeze an oxygen right there into that position. So we end up with this molecule right here. What about K2Cr03? K2Cr03 oxidizes alcohols as well as aldehydes. So that means we're going to have to pay attention to both of these functional groups. And what I'm going to do is redraw the original molecule without making any changes to it first, and then I'm going to edit that drawing to reflect the changes. So the first thing that an oxidizing agent is going to try to do, is convert a single carbon-oxygen bond to a double. So let's take a look down here. Do we have a single bond? Yes, we do. We've got a single bond right there. And when that happens, we have to erase the hydrogen off of the end of the oxygen to reflect the structure of the ketone product right there. And do not forget, there is a hydrogen right here in the line structure. Easy to see. The second thing these reagents are going to try to do is squeeze an oxygen atom in between these particular carbon-hydrogen bonds. So that is going to give us this molecule right here. Let's try one more. K2CR2O7 and Tollens Reagent. Two different reactions, and let's see if we get two different products. So I want to start with Tollens Reagent again, only because it is easier. Tollens Reagent is limited in terms of what it can do. Tollens Reagent only reacts with our aldehydes. So starting with Tollens Reagent, again, because this is a big molecule, I would like to redraw the whole molecule. And I'm going to focus on just the aldehyde group because that is the only part of the molecule that can be affected by Tollens Reagent. The first thing that an oxidizer wants to do is turn a single bond into a double bond, but we already have that double bond, so it can't do that. The second thing it wants to do is squeeze an oxygen into that carbon-hydrogen bond. So that's what it's going to do. So we are going to get an oxygen squeezed into that bond. Let's try the potassium dichromate, K2CR2O7. This works on aldehydes and also alcohols, which means that it is going to be reacting with our alcohol, and it's also going to be reacting with our aldehyde. The first thing that it wants to do is create a carbon-oxygen double bond. Don't forget to get rid of that hydrogen, and let's just draw this hydrogen in just for the heck of it. The second thing that it wants to do is squeeze an extra oxygen into that carbon-hydrogen bond right there. So we will end up with OH, and we're going to squeeze another one in there. So we end up with OH. Can we squeeze an oxygen into either one of these bonds right here? The answer to that question is no, we can't, for two reasons. First of all, this functional group is a ketone, which is not one of the options of what we can react with Tollens or K2CR07. Alcohols and aldehydes only. So ketone is not eligible. So that's first of all. Second of all, this whole squeezing in the oxygen business only works when this is a carbon bonded to a hydrogen or a carbon bonded to a hydrogen. Both of these are carbon-carbon and carbon-carbon. So for two reasons, nothing is happening to that particular functional group.